Rock Health and Wellness Center, and this is Life with Jason Clemmons, DC. We are live from the Rock Health and Wellness Center studios on this Thursday, February 22nd, and we are also live on 98.7 Walk by Faith Radio and 1420 AM Lubbock Christian Nation. Hope you guys have had a fantastic day. Hope you've had a fantastic week. It's been beautiful in Lubbock. These last few days have been sunshiny. It's been great out there. We've been in the office working all day long, working on people, and it's been great at the Rock. We've had some really amazing cases this week, some really challenging things come in the door, and some people that need some help. And I'm so excited to have the opportunity to get to work with those people and see if we can make their lives better. And so it's just been really good. We had a good show last night. If you guys didn't see it, I shared with you the book called Deception by Rand Paul about the COVID cover-up. And I know a lot of people, I had a few conversations about that today in the office. And you know, there's a lot of people out there. I had one of them actually with a state police officer. And he was like, you know, you talk about this with some people and they just don't believe that it could possibly be true. And he has some really strong evidence in multiple areas about some stuff. And it's supporting that whole idea. So, you know, I think that was a big deception. I think that was some gain of function stuff that was going on, and so does Rand Paul. And so he wrote a book about it, and we went over it last night. I'm not going to get into it tonight, but I do think if you want to know a little bit about it, I try not to be a sensationalist, and I try not to be a conspiracy theorist. But I think it's important when it comes to your health to know all of the different dynamics that go on about your health. So, and some of the things that are in play when it comes to your health. So, I just think that if you're living in a like a ostrich with your head in the sand because you just don't want to talk about some of the things that are going on out there, then I think it will end up causing you trouble down the road. So that's why we talked about the book. We talked about the book because I want you to be healthy. I want you to have a healthy life, and I want things to go your way. So that's what we're doing. So tonight, what I thought we'd do on Tuesday, I got to go speak to that WISE group over at Lake Ridge Chapel, and it was a lot of fun. Those are really fun people to talk to, and I've gotten to see a few of them this week here in the office. But we did a talk on diabetes. And we've talked about diabetes before, but there's some new slides and some new thoughts and some new concepts that I've put together. They're not new for, in human history, but the way we've kind of put them together, I thought it would just be a cool night tonight. We try to get a little bit more technical on Thursday nights. And so I thought it would be a cool night to just kind of go through this whole slideshow. You guys can comment about it if you'd like. If you'd like to send a text, you can send us a text at 806-794-0400, and I'd be glad to answer any of your texts that you want to send in. So, and you got any questions about it? So if you want to send me a message on Facebook, YouTube, or X, go ahead and do that. We'll try to get that to you as well. So let's get into it because I think it'll probably take us the majority of the show to work through it, and so we're gonna talk through it. I'm gonna show the slides on the social media for the people on the radio, but I think there'll be enough description on it that you'll be able to follow it pretty clearly, and we can just kind of work from there. So, the title of the talk is "Make Life Sweet, Not Your Blood," and you might ask yourself, why would a chiropractor talk about diabetes? Really, is it outside your scope of practice? Should you be talking about something like this? Shouldn't it be someone else that deals with that's talking about it? And those are legitimate questions, and I understand them. But when we're working on something, in order to make it inside of our scope of practice, it has to be able to, it has to fit inside with some parameters there. It has to fit inside our scope of practice. And what diabetes does is it destroys the nervous system. And from from a nervous system doctor, from a doctor that works on subluxation, and my whole job is to detect and correct subluxations and interference in your nervous system, then it's super important for me to address those things that destroy your nervous system and destroy the physiology in your body that changes your nervous system and destroys the way that your brain functions. And so to me, when I look at something like diabetes, I don't look at it any different than um, a bad pair of shoes or the wrong pillow or a worn out mattress or abnormal posture at work at your desk. It's no big deal for me as a chiropractor to talk about a pillow. It's no big deal for me as a chiropractor to talk about a bed. But sometimes when people say, well, I don't understand why you're talking about diabetes. Well, that's why. So I'm not talking about treating your diabetes. If you have diabetes tonight, then you probably have a diabetes doctor that you talk to. And so you can talk to them about that. But what I'm talking about is tonight, I'm talking about how diabetes destroys your nervous system, and that's what makes it something that we can talk about here in the office. And I just want you to know, when you're talking, it's kind of a very broad term when someone says they have diabetes, because there's different types of diabetes that a person can have that is doesn't always all have the same origin. It doesn't have the same problem. So like diabetes insipidus is one of those things. And it's usually a problem with a hormone called antidiuretic hormone. So the body doesn't make enough antidiuretic hormone or doesn't properly respond to it. And that can cause a diabetes situation. That has nothing to do with your blood sugar. That's not a blood sugar problem or eating too many sweets or that type of thing. So we get into diabetes mellitus, and that involves the high blood sugar and its relationship to insulin. And that's what I want to talk about tonight. And so now you get into, and some people also know like type 1 diabetes or type 2 diabetes. So really what I'm talking about tonight is type 2 diabetes. Type 1 diabetes is when you actually destroy the cells in your body that actually produce insulin, and now you've got to deal with that, and that's a very complicated thing to deal with, and that's a different subject from what I'm talking about tonight. I'm talking about what I want to talk about is I want to talk about type 2 diabetes and the things that it can do to you, and the things that and how it might destroy your body. So I want to make sure that that's very clear. So, what is a carbohydrate? And because it really does get a bad rap. Carbohydrates get a bad rap. They especially nowadays that we have the keto diet and we have the paleo diet and we have all these different kinds of diets, then we get this idea that there's only that you never should have carbohydrates, and I just really don't believe that. I don't think that that the people that push that idea, like you see it on social media all the time, like you just should be straight carnivore or you should be straight keto or whatever. To me personally, I don't think that's necessarily the way to go. And because what we're talking about is I don't see any evidence, actually. I don't see any evidence over probably the last, I don't know, 5,000 years of human existence that a person should never eat carbohydrates of any kind. I don't think that's probably true. And I don't see any evidence where one group, the way that they eat, outlives another group. I don't see that either. I don't see a bunch of 115-year-old carnivores running around and without, and everything's fine with them. So when I look at our diet, I try to look at things that we can sustain over a long period of time. What kind of diet can we get on that is not a fad? It's not something that is a quick fix for something. It's something that we can live with for the rest of our lives. It's something that we can actually we can stick to for the rest of our lives and live a very good, enjoyable life and be well all the way through. Right? So what is a carbohydrate? Well, a carbohydrate is when a plant takes carbon dioxide from the air, and carbon dioxide is one carbon and two oxygens, and it breaks the bond with the two oxygens and it releases them into the air. So everybody knows that, right? Your plants give off oxygen. You give off, that's why the rainforest is a big deal, right? That's why having live plants around town is a big deal. Your plants give off oxygen. And um, and so your plants take that carbon atom and they hydrate it. They add water to it, and they basically take that carbon atom and they add water to it, which makes it a carbohydrate. That's as simple as it gets right there. So cells turn carbohydrates into energy so we can function. And carbohydrates are used in structures such as DNA for the proper burning of fat, to eliminate toxins and excess cholesterol from the body, and are vital for the growth of beneficial bacteria that live in our intestines. So without carbs, you wouldn't be able to think, move, breathe, or even live. And without enough carbohydrates in our diet, the body will begin to burn protein for fuel, causing us to lose muscle. So I just don't I don't believe that if you're really looking for something that you can sustain over a long period of time, that you should have any problem with certain carbohydrates. The question is, what kind of carbohydrates should you eat? That's where we really get into that's what becomes super important right there. Because there are different kinds of carbohydrates. There are and there are simple carbohydrates and there are complex carbohydrates. So what is a simple carbohydrate? Like what does that mean? Well, you see the molecule. You've got the carbon molecule in the middle, and you've got it hydrated. So you got a hydrogen on one side, and then you have a OH on the other side, and you add that. So that's your little molecule that you have. So just imagine that we could stack those little molecules together, and we could stack them up in a very simple straight line chain, basically. Just something that's very simple. Maybe it's got one or two straight line chains. Maybe it's got three, but there's something that's very, very simple to deal with. And I always think of this little puzzle. And you guys listening on the radio, you've known like that little wooden puzzle that's got the yellow little pegs coming out of it that you would give to like a 3-year-old or a 4-year-old, and it's got, like this one we've got a picture of right here. It's got a horse and a cow and a barn scene, and it looks like a dog or something, or a rooster. It's got just like there's six little animals, and you give that to a 3, 4, 5-year-old little kid, and it doesn't take them 5 minutes to figure out how to do that puzzle. They can get that thing all done, put the pieces back together, turn them, put them in there like they're supposed to, and it's really, really quick. That little puzzle is very simple to put together. Well, in our digestive tract, breaking down a simple carbohydrate is really easy for our digestive system. It doesn't take a lot of work. It doesn't take a lot of time. It's really quick. It hits your stomach. I mean, you're chewing it up. It's already getting broken down. It hits your stomach. The acid's got it. Boom, you're there. You already got it broken down, and it's quick. And what happens is now that it will make your blood sugar go up really fast. It will increase the level of glucose in your blood sugar really fast when you have a simple carbohydrate. It's just a very short chain, maybe 1 or 2 branches, something that's really simple, and it's not complicated to break down at all. A complex carbohydrate, on the other hand, is different. A complex carbohydrate is still going to get broken down. You're still going to have that same glucose at the end of it. There's no question about that. But it's like, I've got a picture right here. It looks like a toy store, a toy store. It's harder to say than you think. And what it really is a picture of a 1,000-piece jigsaw puzzle. And it's got all kinds of colors in it right there. And it looks like there's like a staircase, and all kinds of colors in there. And you can just imagine how long, if we started to put that 1,000-piece jigsaw puzzle together, how long it would take us to actually put it together. It'd take us a long time, right? We couldn't, you give that to a 4-year-old, they'd never get that figured out. Like, to give it to a 40-year-old, and it'd take a long time to get it figured out. So a complex carbohydrate has to be broken down, and just imagine we got a long chain of those carbohydrates, and then we got another long chain of those carbohydrates. And then we have another long chain, and then coming off of those chains are side chains, and coming off of those side chains are more chains. And so it's just like, man, the whole room is now filled with all of these carbohydrate chains linked together, these molecules that are linked together, and now it's complicated to break down. So when you start to chew it, it takes a while. Like if you just take an apple, for example, and you start chewing on it, or you start chewing on some vegetables, and you eat some broccoli or some spinach or something, and some salad, and you start chewing on that, it takes a while to break it down. That complex carbohydrate has to be broken down into monosaccharides and disaccharides, the smaller simple sugars, which takes time. This causes blood sugar to rise more slowly and decreases insulin resistance. It decreases insulin release. The cells become energized and the body is happy. Refining complex carbs removes most of the fiber and many essential nutrients. And so if you think about it, what is a complex carbohydrate versus a simple carbohydrate? One of the ways I like to think of it, in almost all cases, there are some cases like white potatoes that are pretty simple, but sweet potatoes are less simple, and purple potatoes are the most less simple. So but that's just for potatoes. So let's just think about the difference. The difference is, let's use broccoli. And I know everybody out there loves broccoli. And I know tonight you're probably going to just cancel whatever you're eating for supper, and you're probably just going to flip it over and start having some broccoli after this talk, right? But let's use broccoli as an example. Broccoli grows in the field, in the dirt. The farmer brings the broccoli out of the dirt, basically takes it and washes it off and puts it in the grocery store. That's the process of taking a complex carbohydrate to the grocery store, and then you're going to take it from the grocery store and put it on your plate. That's about it. There's nothing else going on with that broccoli. It's pretty dang simple. A sweet potato is the same thing. A sweet potato is going to go from the field all the way through to your store, and you're going to put it on your plate. The spinach is going to do the same thing. Your lettuce is going to do the same thing. Like, that's what's going to happen. That's how we get complex carbohydrates, is we just eat food that's just natural food. Now, what is a simple carbohydrate? Think about that. Let's talk about Frosted Flakes. Let's talk about Frosted Flakes or Fruit Loops or Lucky Charms. All of those cereals that we eat, right? Okay, do Lucky Charms grow in a field? No. No one plants and harvests Lucky Charms, right? There's nothing about that grows in a field. So let's reverse it. Let's take it from the grocery store. How did the grocery store get it, right? It had to come from a factory where it was put together. Well, what was put together? The ingredients on the box. So where did the ingredients on the box come from that went in the box? It came from the factory that broke down the thing that grew from the field, right? We took something from the field, we took it to a factory, and we refined it. We broke it down, and we processed it, and we added bleach to it, and we separated it all out, and we did all the things that you do to it in these big factories with the Industrial Revolution. And we take that thing that was growing in the field and we process it through a plant, and then we turn it add a bunch of sugar to it, and then we put it in a box, and then the box ends up in the grocery store. And what we do is we go to the grocery store and then we read the labels to see if it's something that we should be eating. And it's like, hey, doc, what do you think about this? When we do the shop with the doc and we look at labels, people will say, what do you think about this? Do you think I should be eating that? And it's like, I can tell you right off the bat, if you're reading the label, you're already losing. Is there some things that you can read the label on? Are there a few things that you can eat that you can actually read the label on and get away with it? Yeah, there are. There's some things that you can eat. But for the most part, if I'm reading a label on a box of Lucky Charms, which I ate 5,000 boxes of Lucky Charms in my life, to tell you the honest truth, I don't know if I ever read the label on the Lucky Charms because all I wanted was the sugar and the marshmallows from the Lucky Charms, right? So that's a simple carbohydrate, and a simple carbohydrate is going to make your blood sugar go up fast, and it's going to make insulin come up. A complex carbohydrate is going to make your blood sugar rise very slowly and almost get very little or no insulin release. That's the difference between the two right there. So how does that kind of work inside of our body? And glucose is blood sugar. And your body needs glucose in order to function. Your brain needs three things. Your brain needs glucose, it needs oxygen, and it needs excitability. And we've talked about that before. If you've been sitting there and you're very still, and then all of a sudden you just jump, what is that? Why do you do that? You ever done that where you're super still and you just got your foot just sitting there, and then all of a sudden you just kind of startle yourself. You just kind of jump. Well, look here. Your brain knows exactly where you are in space at all times. I can tell you right now I got my shoes on. I can tell you right now that my feet are touching the rail on the bottom of this stool that I'm sitting on. And I'm sitting. I can tell you that. I got my pants on. How do I know that? Because I can feel my pants on my leg. I can feel my shoes on my feet. I can feel my feet on this rail on the bottom of this stool. So that's excitability. That's feeling that's coming into my brain. Well, if I ever get super still and my brain loses my feet in space, I'll just jump. It'll make me jump because it's like, hey, where's my foot? Because I can't just have my foot just hanging out over here and have a tiger come by and just eat my foot off, right? So my brain wants to know. So that's excitability. The next thing is oxygen. You got to have oxygen, right? You have a stroke, you cut the oxygen off to your brain doesn't work. So that's not a good thing. So everybody knows you got to have oxygen to your brain. Just fall into a frozen lake and get stuck under the ice for 7 minutes and see how your brain works out. It's not going to work out good, right? The third thing you got to have is you got to have glucose or some form of it in your brain. You got to get that to your brain. So, but your body tightly regulates that because whenever you add glucose, whenever you add sugar to something, it makes it thick and sticky. That's what happens when you add sugar to something. It makes it thick and sticky. So when you add sugar, like spilling Kool-Aid on a countertop. Anybody that's ever spilled Kool-Aid on the countertop and you try to wipe it off with a dry paper towel, what happens to the paper towel? It sticks on the countertop, right? It sticks on the countertop because it's sticky, because it's got sugar water on it. So whenever we increase our blood sugar, we increase the thickness of the blood and we make it very sticky. And that's super hard for the heart to pump. The heart has a hard time with that. And we got to get, and I'll show you here in just a second, we got to get all that blood through our capillaries that are very, very tiny. And in order to get that thick, sticky blood through our capillaries, it needs to be thin enough to get through there. And if it gets too thick, it'll get stuck and then we won't be able to get it through there. And then we'll lose our ability to get the nutrients and the oxygen to our cells. So we have a thermostat inside our body, inside our pancreas. We have a thermostat. And that thermostat or that gauge is measuring how much glucose is in the bloodstream. It's not a literal thermostat, but you understand what I'm saying. So now you've got your pancreas, and it's monitoring all the time. It's monitoring how much glucose is in your bloodstream. So you eat 2 saltine crackers, and your blood sugar, it ought to be less than 100. Over the years, we've kind of pushed that level up. So now we think that 100 is okay. But over the years, it was below 100. But let's just say 100 is our resting glucose level and it's acceptable. Well, if we eat 2 saltine crackers, it's going to take it to 180, roughly. Okay? Just eating any refined carbohydrates, eating the bowl of Lucky Charms, eating anything that came from the field to the factory, got put in a box, brought over here. Anything that's refined and processed is going to dump glucose in very quickly because it's not very complex to break it down, and it's going to make your blood sugar rise very fast. Well, as soon as that blood starts to flow through your pancreas, that blood is going to be like too thick and too sticky and have too much glucose in it, and your pancreas is going to set off an alarm. And that's going to say, hey, no, don't do that. And that's when we're going to release insulin. So insulin is going to follow glucose. So glucose is going to go up, insulin is going to follow it, and it's going to go up as well. And so then there's a process that goes on, and we're going to take a break here on the radio, and then we'll come back in just a second, and we'll talk about this process that happens on the other side of the break about how we actually use insulin to get that glucose out of the bloodstream, and we get our resting glucose levels back down to normal. So you guys stick around on the radio. You guys hang with me on social media, and we'll be back with Life with Jason Clemmons right after these messages. Yeah, so if you guys, and I'll take this opportunity to mention this because I've mentioned it before, but Justin Richards does a great job on Instagram. Insulin Resistance 1 is the page on Instagram, and he does a fantastic job of eating foods. He's got one of those little patches on his arm. He'll eat something, and then he'll show you what it does to his blood sugar. And that's just one person. I understand that, but it's kind of nice to know. Another way you can test it is you can look at foods on the that have a glycemic load. You got the glycemic index, but you really got the glycemic load. What are the foods, and how is that? What that basically means in very simple terms is that how quickly it's going to make your blood sugar go up. So the higher it is on the glycemic index, or the higher glycemic load it has, is how quickly it's going to make your blood sugar rise. And so there's things that, like sugar, is going to obviously, very simple, it's going to go up very fast. Refined carbohydrates like rice and pasta and bread and those type of things are going to make things, a lot of times fruits will do that. Fruit is a lot of fructose, but like grapes kind of hit you pretty hard. Bananas will hit you pretty hard. And so it gets that white stuff. White potatoes, white rice, pasta, white bread, all those things are pretty much just straight refined glucose. And when you eat them, then your blood sugar is going to rise really fast. And so your pancreas is going to have to get that glucose out of there, or you're going to end up with problems down the road. And so we're just about, give me 1 second. We'll be back from this break. Okay, everybody, we're back. This is Jason Clemmons. This is Life with Jason Clemmons, DC, and we're breaking down diabetes tonight. And so, whenever you eat something that's got refined carbohydrates, that's got very simple carbohydrates, your blood sugar is going to go up very fast, and insulin is going to follow it. So, when your blood sugar goes up, and that blood flows through your pancreas is going to set off an alarm. And it's going to release insulin. And what's going to happen is now insulin is going to dock with the receptor because the glucose, and in a lot of the cells of the body, mostly your muscle cells, but some other cells, they use a glucose gate. There's actually a gate that the glucose has to travel through in order to get inside the cell. But that a lot of times that gate stays closed. And I like to think of it as like if you go to Kohl's or Dillard's or someplace like that, and they've got one of those handicap buttons, and you hit the handicap button and the door opens, right? That's the way I envision if Kohl's or Dillard's was the cell, and I had to get inside the cell, but the doors are closed, then I can hit that button. It will open the door, and I can get into the store. Well, same thing happens here. The insulin docks with the insulin receptor. It creates a mechanism that's inside the cell, and then it opens the glucose gate, which allows the glucose to be sucked into the cell and stored for a later time, whenever the body needs it at a later time. So let's kind of walk through that about how that works. And this is going to be a very annoying discussion, but let's start it off. Let's just have a donut and some coffee for breakfast, or let's have our Lucky Charms for breakfast, right? So what are we going to do first thing in the morning? We're going to spike our glucose, and now we're going to spike our insulin. We're going to hit the receptor, and we're going to open the gate. We're going to hit the receptor, and then we're going to open the gate. And then about 10 o'clock, we're going to just have a little, there's going to be something at work, or we're going to have some crackers that we got in our desk, and we're going to hit the receptor, and we're going to open the gate. And then at lunchtime, we're just going to run get a burger or fries, or get some drink a Coke and have a pizza, or go get some Mexican food or whatever we're going to do for lunch, and we're going to hit the receptor, and we're going to open the gate. We're going to hit it again. We're going to open the gate. And then about 3 o'clock, 2 o'clock, we're going to need something to get us through the afternoon. So we got some M&Ms in the drawer, or maybe we got a Dr. Pepper. We're going to hit the receptor and open the gate, and hit it and open the gate. And then we're going to go home, and we're going to have supper, and we're going to have chicken fries tonight. And that's what's going to be for supper, and mashed potatoes. So we'll just hit the receptor and open the gate. And then we're going to but right before we go to bed, we're going to have that little bowl of Bluebell ice cream, because dadgum, you got to have some ice cream before you go to bed. And what do? You hit the receptor and you open the gate. And I know whenever I say that, it's very annoying, right? It's annoying to say that. It's annoying to tell that story. It's just as much as it's annoying to hear that story. But it's also annoying to that cell. That cell just cannot stand it. That cell just hates it being treated that way. Because in nature, long time ago, when those cells were being developed, and those cells were made, and those cells had what they had to eat, that there wasn't a whole lot of sugar. There wasn't much refined carbohydrates. So they're not used to being yelled at like that. But when they're treated and they're mistreated, and you keep hitting that receptor, and you keep hitting that receptor, and you keep hitting that receptor over and over and over again, what happens is the cell just reaches up and pulls that receptor off that cell wall. It's like, no, you're not going to talk to me like that. It's going to pull that receptor off that cell wall. And that becomes a problem, because now what's going to happen to the blood? The blood is going to flow back through the pancreas, and it's still going to be at 200. It's still going to be at 250. It's still going to be at 300. And it's going to flow back through the pancreas, and now the pancreas is going to say, oh no, double alarm, 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 set it off, more insulin. And so now we've got twice as much insulin that's looking for half as many receptors. And now we've got a serious problem, because now we are insulin resistant. Now we're insulin resistant. And now, man, we can't get the blood sugar down. We can't get it down. And that becomes a bad thing. So why is it bad? Well, it's bad for multiple reasons. Glucose and vitamin C are almost identical. In fact, vitamin C is made from glucose, and they both use the same membrane receptors to enter the cell. So they compete for cell absorption. Phagocytic cells of the immune system require high amounts of vitamin C to work properly. How many people know that? How many people know that whenever you feel like you got a cold coming on, that you can increase your vitamin C and it helps, right? Yes, blood sugar of 120 reduces phagocytic index by 75%. I know you guys have seen this slide before. Insulin is involved. Well, let me stop before. Your immune system decreases its function when you increase your blood sugar. Your children's immune system decreases its function when your children increases their blood sugar. So what would make sense? My child's not feeling very well. I think what I should do is bring them some ice cream. Like, does that make any sense at all? Well, I just want them to feel better. You're going to make them feel better by being sick longer, right? That's what we're going to do, is we're going to give them sugar to make them sick longer. That's not really what we want to do, right? We want their immune systems to be able to fight and function. Insulin is involved in the storage of magnesium. Magnesium helps muscles relax and is a cofactor for almost all energy-producing reactions. If you can't store magnesium, then your muscles can't relax and you end up with high blood pressure. You end up with leg cramps. You end up with restless leg syndrome. You end up with all kinds of trouble when you can't handle your magnesium. Insulin causes the retention of sodium, which causes fluid retention, which gives you more high blood pressure. High insulin levels are a potent stimulator for the sympathetic nervous system. So now we've kicked off our stress response, right? We're kicking off that right side brain, adrenal gland stress response. High insulin raises LDL cholesterol. Exercise and movement deficiency has also been shown to cause insulin resistance. If you don't get any exercise or movement, you can increase your insulin resistance. There's 3 types of cells that become insulin resistant in kind of this order. And the first one is your liver cells. Your liver cells, insulin suppresses the liver cells from making new glucose. So why does the liver make new glucose? Well, whenever you eat supper tonight, your blood sugar is going to go up. Hopefully it doesn't go up very much because you're not going to eat a lot of refined carbohydrates. But your blood sugar is going to go up, and then your insulin is going to go up because the blood is going to flow through the pancreas. The pancreas is going to release the insulin. The insulin is going to bring your blood sugar back down. So it's going to start at 100, then you're going to eat supper, and it's going to rise and take it up. Let's say it takes it up to 250. Well, sometime in the middle of the night, that's going to go from 250, and it's going to start to come down. It's going to go to 200, then it's going to go to 150, and then it's going to go to 100, then it's going to start going down to 90, then it's going to go to 80, then it's going to go to 70. And remember, what 3 things do we need in order to function? We need glucose, oxygen, and excitability. And your brain is working all night long. And that's why you wake up in the morning alive. If your brain quit working in the middle of the night, you wouldn't wake up in the morning alive. You'd wake up in the morning dead. So you want to make sure that your brain keeps working, and your brain wants to make sure that it keeps working. So it is not going to let your blood sugar in the middle of the night go down very much. So what happens? You kick off the pancreas now is going to go through there. The first thing that's going to happen is you're going to kick off your stress response because it's going to set off an alarm in your brain, and your cortisol levels are going to rise. And your cortisol that gets released from your adrenal glands because you've kicked off your stress response. That's why we have cortisol. It's good for us to have cortisol released in the middle of the night. That way we can keep our blood sugar up. Because when you get stressed out, you release cortisol. Cortisol increases your blood sugar. Now, if you're getting stressed out all the time, then you have a chance of becoming insulin resistant because it's your cortisol levels that are keeping your blood sugar up all the time. That's why you end up with trouble losing weight and type 2 diabetes and that type of thing when you're stressed out all the time. So, but when that blood travels back through the pancreas and it's already down to 90, 80, 70, that sets off an alarm in the pancreas, and the pancreas is now going to release a hormone called glucagon. And glucagon is going to tell the liver to start making glucose. It's going to say, hey, I know you've got that stored up glucose inside your cell, so cut the tail off of that dude, release it back into the bloodstream so we can get our glucose level back to 100. So that's exactly what happens. The liver cells are kicking that glucose back into the bloodstream. So now it goes from 70 and it goes back up. It goes to 80, it goes to 90, it goes to 100, it goes to 110, it goes to 120. It flows back through the pancreas again, and now the pancreas needs to tell the liver to stop. Hold up, stop right there. And the pancreas now is going to release insulin to tell the liver to stop. But if the liver cells have become insulin resistant, now we've got a problem right there because with the liver cells being insulin resistant, now there's no way to tell the liver to stop making glucose. So if the liver cells are resistant to insulin, then throughout the night, when the body should be moving the fat, burning up fat, the liver is making more glucose, so you wake up with elevated blood glucose in the morning. That's why if you're diabetic, they ask you to take your blood sugar first thing in the morning. If you wake up in the morning and your blood sugar is at 300, what does that tell you? That tells you that your glucose, your liver was making glucose all night long, and nothing could shut it off. There was no way to tell it to stop. So it just kept making it. Well, whenever the liver runs out of glucose, it's going to send a signal to the rest of the cells of the body, and it's going to say, send me your glucose. And so the body's going to send the glucose that it's stored up in your arms and in your legs. It's going to send it to the middle of your body, and then your liver is going to get all of this glucose over there, and you're going to end up with what's called centripetal obesity. And now the middle section of your body is going to be big, your legs are going to be skinny, your arms and shoulders are going to be skinny, but the middle of you is going to be big and round, and that's centripetal obesity, and that's a bad thing. And one way that you can judge it is measure your butt. Measure your butt and measure your belly. If your butt is bigger than your belly, you're just fat. Don't worry about it. Deal with that in other ways. If your belly gets bigger than your butt, that's a problem. Because now you've got centripetal obesity, now you've got fatty liver, now you've got visceral fat, and that's where things start going south on us right there. The next cells that become insulin resistant are muscle cells. Insulin allows your muscles to burn the sugar you are making in the liver and getting from the diet. When your muscles become resistant, you can't burn up the sugar, so there's too much sugar in the blood. This in turn leads to more insulin production, more insulin resistance, which leads to changes in magnesium, sympathetic stimulation, sodium retention, high blood pressure. Right? Then the fat cells, and those are the last ones that become insulin resistant, and then we end up with this problem. That's where we get our centripetal obesity, right? So we don't want that to happen. Insulin resistance increases osteoporosis. The liver converts T4 to T3, which is our inactive to active form of thyroid hormone. So when the liver can no longer listen to insulin, it doesn't convert T4 to T3 very well. So now you end up with thyroid dysfunction. Insulin is involved in the regulation of estrogen, progesterone, and testosterone. So now what happens? Your hormones get all out of whack. That's not good. High insulin causes increased aging. That's not good. So those are all the things that happen whenever you're dealing with high insulin, high glucose, and when you're dealing with high glucose and you're dealing with insulin. But here's a whole nother realm right here. Here's a whole nother part of the problem. Some cells do not require insulin to bring glucose into the cell. If blood sugar is elevated, it diffuses across a cell membrane to the small nerves and blood vessels. So it's just like burning toast, and we've talked about this before. It's just like burning toast in your kitchen. Have you ever burned toast in the kitchen and somebody in the living room says, hey, is something burning? Yes, everybody's experienced that. Everybody knows if somebody burns toast in the kitchen, somebody in the bedroom, you'll be able to smell burned toast in the bedroom. Why is that? Because that smoke from the burned toast, which you shouldn't be eating in the first place, but anyway, it's burned. That burned toast smoke is going to diffuse. It's going to go from an area of high concentration to an area of lower concentration. That's what it means to diffuse across a membrane or diffuse in an area. You there's a lot of smoke in the kitchen. The smoke starts to move where there's no smoke. It goes into the living room or the bedroom, and now you've got smoke everywhere. That's what diffusion is like. Well, same thing happens inside of our body. And the two main blood vessels, the two main cells that don't use insulin are very small unmyelinated nerve fibers and very small blood vessels. Neither one of those cells need insulin in order to store glucose. So if you've got high levels of glucose in your blood, then what will happen is that will just diffuse across the membrane, and it will diffuse from an area of high concentration to an area of low concentration. And when it does that in that nerve, then what's going to happen is the nerve is going to store that glucose in a product called sorbitol, and sorbitol is going to attract water. And so now we take the glucose from the bloodstream and we put it into the nerve cell, and then it pulls water with it and it swells it up. It swells up the nerve cell. It swells up the tissue because there's water around it. And when it swells up the tissue and it swells up a nerve, it sets that nerve off really quickly. It changes the threshold by which that nerve will fire. Where you kind of gotta hurt. I mean, you gotta hit something pretty hard in order to make that sting. But if I've got neuropathy in my hands, and I've got it because that my hands get all swollen up, or my feet get all swollen up because I've got neuropathy in my hands or my feet, then what happens is that sets it off really quick. And when it sets it off really quick, you just barely put your foot on the ground and it hurts like heck. And that's not good. That's not good at all. We don't want that to happen. The other part is when we get into these capillaries. And so there's a system, the hemoglobin that picks up the blood, the oxygen from the lungs, and it travels through the blood. When it gets down there to those very small capillaries, when we're going to get oxygen exchange into the tissue, we got to get down there to almost a single cell layer thick. Like that's it. We got to be able to do that to get down to that level. Well, when we get down to that level, what happens now is if we've got swelling in those little capillaries because the glucose has increased the water, now it clogs it up. And when it clogs it up, that becomes a problem for us. And now we can't get the nutrients. We can't get the nutrients from the blood or the oxygen from the blood into the tissue. And those very small blood vessels become clogged up. And you can see them sometimes because you can see them you can see them on your arm or you can see them on your leg where you got these little red lines that are going on. That's your red blood cells getting stuck inside those small capillaries. And there's a bypass system. There's a bypass that lets the artery move on past and keep the blood flowing, but it stops going to the capillary bed and it stops getting that oxygen. So now we start to lose that. And the small blood vessels of your eyes are one of the area. And the further you go away from the heart, the smaller the blood vessels get. So you get down into your hands and feet and you end up with having that neuropathy because you've got those swollen cells and you've got those in multiple ways right there. So those are two ways from glucose. That glucose from the standpoint of food, right? When we eat refined carbohydrates and we increase our insulin over time repetitively, we become insulin resistant. When we increase our blood glucose from simple carbohydrates and now we get too much in our blood, it just diffuses across. Both of those ways. But here's another way right here. Here's a third way that you can also cause trouble with your insulin, and that's by being stressed out. And you guys have seen this lots of times. The right side of the brain deals with the unknown world. It thrives on adrenaline. That's where you're going to fight your tigers. You're going to kick off your sympathetic stress. Well, dopamine is on the other side, your left brain. That's the part that deals with no threat. That's the part that works out the details of things, right? Well, if we're stressed out all the time, and now we're driving those cortisol levels high. Chronic stress causes the release of cortisol and aldosterone, which is another hormone that's released from your adrenal glands, and some sex hormones. So chronic stress causes the release of cortisol and aldosterone and some sex hormones. Cortisol is to elevated blood sugar. Cortisol is the function of cortisol is to elevate blood sugar while we're sleeping. It also elevates aldosterone, which causes us to absorb more salt. So when we increase our aldosterone, our kidneys will absorb more salt. And when they absorb salt, water follows salt. So it would increase our blood pressure. So in the middle of the night, in order to keep our blood pressure as stable and to keep our blood glucose levels stable, then the adrenal glands are going to release cortisol and aldosterone together. And that's going to keep us to maintain it. But if we're under chronic stress, like short-term elevation of cortisol leads to elevation of blood sugar, which can contribute to insulin resistance. Reactive hypoglycemia, where you overcompensate with insulin, then you end up with insulin resistance. Those two things are super important right there. But what also happens inside the body is when we're stressed out and we release cortisol. Well, cortisol is based on cholesterol. There's a relationship right there. So we're in this world of statin drugs where we're constantly trying to push our cholesterol down. You got to keep your cholesterol down. Keep your cholesterol down. We don't ever take into consideration why the cholesterol was high in the first place, what caused the cholesterol to be high in the first place. None of that. We just say, well, your cholesterol is high, so we're going to drive your cholesterol down with statins. But the problem is we didn't drive your stress level down. So your stress level is still high, and your cholesterol level is low. And if cholesterol is not high and a person is under stress, then cortisol will steal cholesterol away from estrogen, progesterone, testosterone, and other sex hormones and deplete their reserves. So now you can't use the cholesterol to make your testosterone and your estrogen and your progesterone that you need to make, because the cortisol is stealing that cholesterol. And now because we got to keep that whole blood sugar thing going, because our brain is fighting tigers all day long. Now you lose the ability to maintain blood sugar appropriately, and you lose anti-inflammatory status, because there's anti-inflammatories that are involved in that whole process. When you lose that level of inflammation suppression, the small vessels will swell and get the red blood cells to get stuck. You can see this by seeing the red blood vessels. That's what I was talking about a while ago. You can see that inside your body whenever you're under this level of stress. So being stressed out has a component of insulin resistance, which has a component of destroying your nervous system, and so that's not a good thing. So there's a couple, that's 3 levels that we talked about right there, that we can have damage. We can have insulin resistance, we can have too much glucose in the bloodstream, and now we can be stressed out. So Dr. Kipner, you've seen this, put diabetic patients on a diet high in complex carbohydrates. Within 3 months, most patients on his diet experienced a significant decrease in blood pressure, blood sugar, weight, insulin requirements, cholesterol, sugar in the urine, and protein in the urine. Studies done by the American Journal of Clinical Nutrition, the British Medical Journal, Diabetes Care, Lancet, and others have confirmed Dr. Kipner's work. Dr. Kipner was a postgraduate. He did postgraduate medicine in 1958. He put these people on a high complex carbohydrate diet in 1958, and they got healthy, because the same physiology that was in 1958 is the same physiology that's in 2024. It's nothing new under the sun when it comes to what we should be doing. We should be eating complex carbohydrates, and that's what we should do right there. So we should watch our blood sugar by eating complex carbohydrates, meat and vegetables, nuts from a tree, berries instead of fruits, just a little bit of berries, and stay away from refined carbohydrates. And the other part is control our stress. So that's the show tonight. I hope you guys enjoyed that. I hope you got something from it. I know we've done it before, but I just felt like it was, since I had some new slides on there, it'd be really good to do again. We will not be on the show tomorrow night. I'm going to go to Ruidoso, New Mexico with Dr. Fraley and have another great seminar this weekend. So we've got an encore show on the radio, and we will not have the show tomorrow night. We will see you guys back in the office on Monday at 6. You guys have a great weekend.